There we go. It's recording. Okay, so today what we're doing is we're going to be factoring perfect cubes. Okay, so before I start, let's put down some numbers that we know, okay? We know that 1 is equal to 1 cubed. I mean, that seems obvious, but it's going to be helpful to write that down. We know that 8 is the same thing as 2 cubed. We know 27 is the same thing as 3 cubed. I know 64 is the same thing as 4 cubed. 125 is 5 cubed. 216 is 6 cubed. I think it's 343. Oh, I don't know. 343? What is 7 cubed? I think it's 343. Yes. 343 is 7 cubed. 512? 512. Okay, hold on. 8 cubed. 512 is 8 cubed. Anything beyond that, we're just going to need a calculator to figure it out, okay? So, let's write down our two formulas on the top. My first formula right on the top is, I'm going to put the ones that are on the board. I'm going to rewrite those so we have them. I have a cubed plus a b cubed is a plus b, a squared minus ab plus a b squared. Okay? And the other one I have is the difference, which is just a cubed subtract b cubed is equal to an a minus b and an a squared plus ab plus b squared. Okay? So if I have the formulas on my notes, it's helpful. I also, of course, have them up here. So I've got them here. I'm going to leave them up here because I don't expect you guys to memorize, okay?
Thank you. Mr. Davies, you think this is hard, man?
No, this is not hard.
See, I told you.
No, that's not hard.
See, I told you.
She's saying it is like, she thinks we're special, man.
No, this is not hard.
Not yet.
So you ready? Let's take a look at example 1. So example 1, I could rewrite this problem as 2x cubed minus 5 cubed. Okay, now I'm going to write that up there. This is really important that you see what I did. I have to have cubes. 8 is a perfect cube, but it needs to be written as 2 cubes. Does that make sense? We got that? Do you understand? Wait. Do you understand why I did this? 2. There's my 8. Isn't that 8?
Yeah.
Isn't 2 cubed 8?
Yes. Oh, yeah.
It isn't 5 cubed. Isn't 5 cubed 125? Right? Cassie.
So 2x cubed is the same as 8x cubed?
Yes.
What?
Yes.
To the
Because
cube of 2.
what is
2 to the third
2x
power
times
is
2x times 2x?
2 times 2 times 2. 2 times 2 times 2.
It's
Yes.
8.
It's 8.
And x times x times x is?
X cubed.
X cubed.
Yes.
No, but don't you have to add, but 8x cubed does not equal 2x cubed. Like the
Okay,
answer.
so x is cubed, but 8 is just 8. This cube does not go to 8. This cube doesn't touch 8. But I can write it as.
Because it's the exponent for
Oh, I could do it this way too.
We don't know what
I
X
have-
is, so that's as close.
How's this? Is that another way to write it?
That's confusing.
Is that another way to write it?
What?
There's 8 x cubed. There's 8 x cubed, right? Isn't that 8 x cubed? Right?
Yeah.
Or wouldn't it be easier just to write it as, so they're both cubed? Okay, so now, let's use the formula. So on the formula, we're going to let A is going to equal my 2x, and my b is going to equal my 5, right? Because I have a cubed minus b cubed, okay? So we're going to take our formula. It's the subtract one, so we're going to use this second formula. See the subtract? I'll highlight it. So we have the subtract. We have the subtract here. So I'm going to use the formula of a minus b times a squared plus ab plus b squared. Okay?
Wait, why are you using that one again?
Great question. See the subtract right there.
Oh,
Great question. Thank you, Brian. Do you agree?
yeah.
Now, I'm just going to plug it in. So I'm going to write, well, a is 2x minus b is 5. So I just put my 2x in for a, my 5 in for b, and then I'm going to go 2x squared, which is don't let this spot, 4x squared. Where'd the 4 come from? Where'd the 4 come from? A squared is the same thing as 2x squared, which is a 4x squared, right? Plus a 10x. Where'd the 10x come from? That 2x times 5, right? Plus 25. Where'd the 25 come from? 5 squared, right? So here's my formula. A minus b, 2x minus 5. A squared is this squared, which is a 4x squared. Plus ab, a times b is a 10x plus b squared, which is 25. You're done. It is factored. You didn't have to do any thinking. You just plug and chug. No, I'm leaving those equations up until we're way done with the test.
Wait, can you leave?
Yeah. This is big brain math. We're doing big brain math.
Can I use the, can I see the equations again? The
They're
very
right,
first ones?
they're right up there on the board,
Oh, what?
on the whiteboard.
Oh, I did not see that, sorry.
Yeah, clearly.
Job never gets boring, does it? Okay. All right, now number 2 is different. It's not one of those. It's what we did yesterday. What do you recognize about it? What do you see? They have a common. Do they have a common? They have a common x. If you can common factor, always do it because it makes it smaller. I'll say it again. Yes, if you can common factor, always do it because it makes it smaller. So then I'd have a x squared plus a invisible 1x minus 2. Now, my trinomial can be factored again. And we've been doing this all this week. X and x times x. What times what makes 2? What times what makes 2? What times what makes 2? 2 and 1. Positive 2, negative 1. Positive 2, negative 1.
Is that the answer?
Yeah, because you can check your double smiley, and you'll get your positive 1, right? Remember your double smiley? You can check your double smiley.
Wait, what if we can't use the double?
Then it doesn't factor. And if it doesn't factor, we're going to learn the thing called the quadratic formula later. Everything you're going to see Brian will factor. Otherwise, we have to throw the question out for now. Okay, how about example 3? What do you see? Anybody have any ideas on example 3? Any guesses? There's nothing to common factor. You can't common factor. It's not one of our new ones. How about if we do this? X squared, x squared. Sure, right? And then what times what makes 4?
2.
2 and 2 is good, but it won't make a 5. 1 and 4. And what if it's a negative 1 and a negative 4, okay?
You wrote a negative 1 and a negative 1.
I did. Thanks, Cassidy. Now, both of these can be factored again.
Again?
Sure, how about x plus 1, x minus 1? How about x plus 2, x minus 2? How about x plus 1, x minus 1? And how about x plus 2, x minus 2?
Wait, why do you, why don't you do x minus 1 and x minus 1?
You wouldn't be able to get a negative 1 with minus 1 times a minus 1.
Well, does
Right?
it make any sense now?
Okay, example 4. How many terms? What do you do when you see 4 terms?
Group.
Group them. So let's group these 2 together and these 2 together, right? Right? What do the first 2 have in common?
X
X squared, right? X squared. And I'd have a x minus 2 left over. Well, these 2 don't have anything in common, but we need to do something. We need something. Let's take out a negative 1, and you'll see why.
What did you say?
So if I take out a negative 1, I'll have a positive x minus 2, okay? So what do these 2 groups have in common?
X. Negative 2.
An x minus 2. And then, what's left over? What's left over?
X squared and a negative 1.
Now, we just did that one again, didn't we? We just did that one again. So we can factor x squared minus 1 again. We just did it, right? So we'll go x plus 1, x minus 1, and it is completely factored. All right, we're doing big brain stuff, aren't we? Right? Okay, ready to turn the page? I'll wait for you. Yeah, why not? We're in Algebra 2 now. Okay, turn the page.
No, 1 second.
All right, I'll wait for you.
1 second is passed.
No, many seconds.
I am patient.
Thank you, Miss.
I'm very patient.
Very happy for your patience.
After 36 years, I've learned a lot of patience. And 2 teenage daughters. Right, you're smiling. You're like, yeah, I get it. Yeah. 2 teenage daughters. That'll do it. Lots of gray hair. It's not even gray anymore. It's white. Okay, ready? All right, here we go. All right, now, example 5. Can we make it smaller? Can we make it smaller? What should we do?
2x.
2x. 2x 6. Good. I totally agree. I'd have a x cubed minus 8. All right? Are we okay with x cubed minus 8?
Yes.
We can do this now. We can because we have an x cubed and we have a 2 cubed. Okay? So let me rewrite it. It really could look like this. X cubed minus a 2 cubed, so that a would be x and b would be 2, right? It's a cubed minus a cube. I'm going to use the formulas on the board. I'm going to use my a minus b, a squared plus ab plus b squared. Okay, I'm using that formula, which is what we have on the board, right? So the 2x to the 6 is still there. So let's plug and chug. We're going to plug and chug. So 2x to the 6 times a. A is x minus b minus 2, good, times a squared, which is x squared, right? Plus ab, which is going to be a 2x, plus b squared, which is a 4, plus a 4. We're done. Okay. How am I doing? Slide it up. I will wait. Yeah, I'll wait. I'm happy to wait, really. As soon as I get in with notes. But you guys got to stop wandering the halls. You're going to get me in trouble.
Well, we need to go to the office.
Okay, example 6.
All this is just a bathroom break, right?
Can we, and we'll just take a bathroom break because we're due. So, can we make it smaller? Can we make it smaller?
Yes.
How do we make it smaller?
2, 4.
Good, totally agree. Okay, we made it smaller, right? So I'll have a x squared minus a 13x plus 42. Okay?
Wait, oh, never mind.
Okay, well, I made it smaller. So what times what makes 42? I hear it. 6 and 7. What's 6 plus 7?
13.
So I think this will work, right? Right? X times x minus 6 minus 7.
That was really easy.
Yeah. Okay, number 7, almost done. So number 7, is x minus 1 a factor? Does it go unevenly? So there's two ways. Two ways. We could divide it. We could divide x plus 1 into x cubed minus 13x minus 12. We could. And we could look for our remainder, right? We could look for our remainder. We could do synthetic division. And look for a remainder, or we could plug in x equals -1, and by doing synthetic substitution, you get the remainder. So we could divide it and look for the remainder. We could do synthetic division and look for the remainder, or we could just plug it in and see what the answer is. So if I plug it in, I'll go -1 cubed. Minus a 13 times a -1
How did you
minus.
get the x's in -1?
Great question. Michael said that earlier, but it's a great question. So if x plus 1 equals 0, right? You minus 1, you get x equals -1, right?
Oh.
Right?
So the x plus 1, if it's like, for any equation, so if it was like an x plus 7, it would equal 0 as well.
Yes. Okay, now I get a -1 plus 13 minus 12. What do you get for an answer? What do you get for an answer? 0. So that's my remainder.
So it's a factor.
Yes, it is a factor because it goes in evenly. The remainder is 0. Okay? So, bathroom break. Okay, bathroom break. Make it quick because I'm going to put the homework out. Okay? Don't